Okay, today we are going to use the graph of a circle, which we use to draw a tangent line and make it into a right triangle, because when the tangent line first hits the circle, this tangent line with the point that the tangent line intersects with the circle, with the center of the circle, is going to form a right angle. So in this case, we made a right triangle from this graph to solve some measurements that we have here. So we're going to use this as a reference to solve some measurements. This is x, this is y, not to be confused with the x and y axis we have on the graph. It's just its own separate thing. We have the radius right there. We have the circle. We have point A, point B, and point C. This is a tangent line. This is, you see this point P right here. This is a this forms a right triangle using the circle. All right, so we're going to use that as a reference image to find some measurements for all of the information that we have here. So it says find the measurements from the given information. Use the graph as a reference. So we're given some information right here, and we're going to use. I'm going to use the graph. We're going to use some trigonometry to find the measurements. So make sure you have your calculator. Make sure it's in radian. It's in degree mode, and let's go ahead and get started. So let's go ahead and start with number 1. It says angle A is equal to 37 degrees. R, the radius, is equal to 15, and find x and angle B. So we're going to use a pencil, and we're going to use our graph. So angle A is equal to 37 degrees. So this is point A, and this is going to be angle A, and this is going to equal to 37 degrees. Right? We're going to have to erase this later when we move on to other problems. That's why we are using pencil. R, the radius, is equal to 15. So this is equal to 15. Could be anything, feet, inches, whatever. So we're going to have to find x and angle B. Let's go ahead and find x. So let's go ahead and use SOHCAHTOA. Let's go ahead and use that. So let's go ahead and use let's go ahead and find x, right? Let's find x first. Yeah, let's find x. So what is the opposite? What is opposite, which is 15, over the hypotenuse, which is going to be x plus this? What will that be? This will be, we are going to use sine, right? Sine, SOHCAHTOA, opposite over hypotenuse. Opposite of 37 degrees is 15. And the hypotenuse is this whole thing right here. So this is a radius, right? This is also the radius. So this little red dotted line we have here is going to be 15. So this whole hypotenuse is going to be x plus 15, right? Because this is the radius. The same thing as this is a radius, all right? So let's go ahead and use sine. Sine, why? Sine opposite over hypotenuse, just how we established. So we have sine of what angle? 37 degrees is equal to what? It's equal to opposite. What's our opposite? What's the opposite? It's 15, right? It's equal to 15 over the hypotenuse. And what is the hypotenuse? Again, it's this whole piece right here. So x plus the radius, 15, right? Dotted line, 15. Red dotted line is 15. So x plus 15. So now we are going to go ahead and solve for x. So let's go ahead and multiply x plus 15 to both sides, right? X plus 15. This is just some basic algebra. So now we have x plus 15 times sine of 37 degrees is equal to 15, right? Let's go ahead and use the distributive property to distribute the thing we have inside the parentheses. So we have x times sine of 37 degrees plus 15 times sine 37 degrees is equal to 15. We want to leave x by itself, so let's go ahead and subtract 15 times sine of 37 degrees from both sides. So we are left with x times sine of 37 degrees is equal to 15 minus 15 sine of 37 degrees. And now let's go ahead and divide both sides by sine of 37 degrees. Sine of 37 degrees. So now we're just put this into your calculator. So let me check my work. 15, 37. All right, let's go ahead and put this into the calculator. Make sure your calculator is in degree mode and not radian mode. So let's go ahead and plug this into the calculator and let's see what we get. We have 15 minus 15 sine of 37 divided by sine of 37. That's going to give us 9. Let's go to one decimal place. So 9.9 roughly equals to 9.9. 9.9. So that's going to be our x. We found our x value. So let's go ahead and find our angle. What's it looking for? Angle B. So it wants this angle. We want to know what this angle is. This is 90 degrees. Remember, right triangle, 90 degrees. So how do we find angle B? That's easy. Remember that a right triangle is always going to be equal, all of its angles is going to be equal to 180 degrees. So we're going to subtract 90 degrees, right? And we're going to subtract 37 degrees. And this is going to give us 53 degrees, right? So angle B is equal to 53 degrees. So that is how you do number 1. Let's go ahead and move on to number 2. So again, we have angle A is equal to 44 degrees. We have x is equal to, I don't know why I wrote a 30 degrees there, but it's not 30 degrees, it's just 30. So ignore the degree. And we have to find x, and we have to find x. We have to find r and angle B. So let's go ahead and do that. Let me erase the thing from let me erase some numbers from our previous problem. Hold on just a second. Alright, so I erase it. Let's see what we're given. We have angle A. Angle A is now 44 degrees, right? 44 degrees. X is equal to 30. I don't know why I wrote 30 degrees, but X is 30. R and angle B. So we need to find R and angle B. So let's go ahead and do this. Let's go ahead and do number 2. So yeah, let's find R and angle B. Let's find R first. All right, let's find R first. So again, we're gonna use SOHCAHTOA. So R, this is R again. Remember, radius R. So we're gonna have to do yeah, basically we're gonna have to do the what do we call it? Okay, opposite over hypotenuse, right? Sine. That's sine, right? Sine is opposite over hypotenuse, SOHCAHTOA. So we're gonna again use sine. We're gonna use sine of 44 degrees. Remember, this is our angle. We're gonna use sine of 44 degrees. Sine of 44 degrees is equal to opposite of 44 degrees. That's r over the hypotenuse. Remember, it's not just 30, it's 30 plus r, right? Because r is right here. This is our radius. So 30 plus r. 30 plus r. It looks pretty illegible, but that reads sine of 44 degrees is equal to r over 30 plus r. I know that looks like an n, but so that's what we're gonna do. Now let's go ahead and solve for r. Solve for r. Again, multiply both sides by 30 plus r. 30 plus r. And so this gives us 30 plus r times sine of 44 degrees is equal to r. Let's go ahead and use the distributive property again. So we have 30 times sine of 44 degrees plus r times sine of 44 degrees is equal to r, right? So again, we want to leave r by itself. So let's go ahead and take all the terms that have r and put it on one side. So let's go ahead and subtract r of 44 degrees from r and just leave the 30 times sine of 44 degrees. So we have 30 times sine of 44 degrees is equal to r minus r sine of 44 degrees, because we subtracted this one from both sides. So now that we're left with 30, let's go ahead and leave r by itself. So how are we going to leave r by itself? Let's go ahead and use some factoring. Let's factor r out of this expression that we have on the right side. So this is going to be 30 times sine of 44 degrees is equal to, let's factor an r. That's going to be 1 minus sine of 44 degrees. Because if we multiply r by 1, that's going to give us r. We multiply r by minus sine of 44 degrees, it's going to give us minus r of sine of 44 degrees. It's just some factoring. So let's go ahead and divide. Now that we have r, let's go ahead and divide by 1 minus sine of 44 degrees from both sides. 1 minus sine of 44 degrees from both sides. Let's go ahead and use the calculator to roughly estimate what r is. So again, this gives us 30 times sine of 44 degrees, right? Divided by 1 minus sine 44 degrees, right? That's going to give us r is roughly equal to, let's round to one decimal place, so that's 66.3, right? 68.3. R is roughly equal to 68.3. 68.3. That's going to be our radius. So our radius is roughly equal to 68.3. Let's go. What else is it looking for? Angle B. So again, we're going to have to subtract. Remember, 180 from this angle. This triangle is always going to be equal to 180 degrees minus 90 minus what's given to us, 44. So what is angle B? Angle B is equal to 180 minus 90 minus 44, 46 degrees. We found angle B. So that is what it was looking for. We found R and B. Let's go ahead and do the last one, which is y is equal to 70, r is equal to 18, and find angle A and X. So again, let's erase our numbers here and put the new ones in. Okay, I already wrote down the numbers. We are given that y is equal to 70, r is equal to 18. I wrote 18 here again because remember that red dotted line is also the radius, and we're going to have to find angle A and we're going to have to find X. So let's go ahead and do this. Let's go ahead and do this. Let's go ahead and find angle A first. So angle A, again, we're going to use SOHCAHTOA. So let's see. That is, what is this? That's opposite of angle A over adjacent. So what does that translate to? That translates to tangent, right? We're going to use tangent because these two values are already known to us. So let's go ahead and use tangent because that is opposite over adjacent. Remember your SOHCAHTOA. Tangent, opposite over adjacent. Opposite of this angle is 18, adjacent is 70. So let's go ahead and use tangent. Tangent of angle A is equal to opposite. What's our opposite? Is 18 over adjacent, which is 70. So that's going to be your angle, this is going to be the value of tangent of A. So let's go ahead and find the angle that this belongs to. So we're going to use inverse tangent. So this is going to be A is equal to inverse tangent of 18 divided by 70, right? 18 divided by 70. Let's go ahead and calculate that with the calculator. So that is shift inverse tangent of 18 divided by 70. That is going to give us 14.4 degrees. We're going to round to one decimal place. So angle A is roughly equal to 14.4 degrees. So yeah, we found angle A. So we already found angle A. Let's go ahead and find x. So x, remember, this is going to be the hypotenuse. So let's go ahead and find x. Let's go ahead, let's find it two ways. First, let's find the whole hypotenuse, and then we're going to have to subtract the radius, which is 18, from it. And then let's go ahead and use the trigonometric functions to see if we can solve for x. So let's go ahead and do the first one first. We're gonna go ahead and use the Pythagorean theorem. So that is a squared plus b squared is equal to c squared, right? So let's go ahead and just plug in our values in there. Let's just say a is 70 squared plus b squared, which is 18 squared, is equal to c squared. So this is just going to give us a whole hypotenuse here. C is going to be the whole hypotenuse. We're going to have to subtract the radius from it, which is 18. So go ahead and bust out the calculator. We're going to have to use, we're going to have to type in 70 squared plus 18 squared. What is that going to give us? It's going to give us 5,224. So it's going to go ahead and take the square root of that. So 5,224 is equal to c squared. Let's go ahead and take the square root of that. C is equal to square root of your answer. That is going to be 72. Let's round to 3. Let's round to 2 decimal 2. Let's round to 1 decimal place at 72.3. So C is roughly equal to 72.3. C is equal to 72.3. That's going to be, oh shoot, sorry. That's going to be your hypotenuse. Ignore that. Sorry about that. Ignore that. So that's going to be your whole hypotenuse. So we're going to have to, in order to find x, we want to find x. We don't want to find c. 72.3, we're going to subtract your radius just to find x. And that is equal to 54.3. So that's going to be x. X is equal to 54.3. We found x. So let's go ahead and find it using the trigonometric functions. So again, using SOHCAHTOA. So let's use SOHCAHTOA. Let's go ahead and we already found this, which is 14.4 degrees. So that's already known. So that is, we want to find x. So we're going to have to use these two values. So that is opposite over hypotenuse. Opposite over hypotenuse, that's sine. So sine of 14.4 degrees. That is equal to opposite, which is 18, over hypotenuse, which is x plus 18. Now let's go ahead and solve it just how we solved all of them. So again, just multiply both sides by x plus 18. Sine of 14.4 degrees is equal to 18. Use the distributive property. X times sine of 14.4 degrees. You guys get the gist of it, so I'm not really going to go that slow. Is equal to 18. Subtract to leave x by itself. Is equal to 18 minus 18 sine 14. Oh, that is messy. But you guys get the idea, right? So, again, we divide both sides by sine of 14.4 degrees. Sine of 14.4 degrees. Yeah, that is disgusting, but you guys get it. You don't get it, just let me know, but it's just solving how we did with the rest of the, what do you call it? Problems we had. So 18 minus sine. That says 18 minus sine of 14.4 degrees. 14.4 degrees divided by sine of 14.4 degrees. That's going to give us 54 point, yeah, roughly the same. Let's just say it's 54.3. So this is just going to say that x is equal to 54.3. So that is how you do it both ways, the Pythagorean theorem and the trigonometric way. So that is how we pretty much solved all of this using the picture that we have here and the information that they gave us. And yeah, that's pretty much it. And Good luck.